Yo, what's up everyone and welcome back to my channel. This is July the IT guy and I'm back here with another Cisco Packet Tracer lab. Today's lab is 5.1.9 Packet Tracer Investigate STP Loop Prevention. So what is STP? STP essentially is a spanning tree protocol, is a layer 2 network protocol designed to prevent loops when you have redundant links between switches. So pretty much in simpler terms, if you connect two switches, for instance, with two different cables for backup, data could circle around forever, theoretically, causing a broadcast storm that crashes your network. So STP acts like a traffic cop, right? It monitors the connections and automatically shuts down one of the extra paths. If the main cable ever fails, STP instantaneously detects it and reopens the backup path so your internet keeps running without anyone ever noticing. So why is it important for your labs? Again, it prevents network crashes, it stops infinite data loops that overwhelm your CPU, automatic redundancy, it keeps your connection alive if a physical cable is unplugged, and it's a silent operation. It runs in the background of your Cisco switches by default. Alright, so what are the objectives here in this lab today? You will observe spanning tree ports states and watch the spanning tree convergence process, describe the operation of spanning tree protocol, and explain how spanning tree protocol prevents switching loops while allowing redundancy in switch networks. A little bit of the background and scenario in this activity. You will use Packet Tracer to observe the operation of spanning tree protocol in a simple switch network that has redundant paths. Alright, so some of the instructions here. Part 1, observe a converged spanning tree instance. Step 1, verify connectivity. So ping from PC 1 to PC 2 to verify connectivity between the hosts. Your ping should be successful. Alright, so let's go ahead and verify that. Let's go over to our lab here on PC 1. Let's open up our command prompt and let's go ahead and ping PC2, which is over at 192.168.1.101. And let's verify it. All right, so there you have it. We do see there are responses. So yes, it is confirmed. PC1 is able to reach PC2. All right, step 2, verify spanning tree status on each switch. Use the show spanning tree VLAN 1 command to gather information about the spanning tree status of each switch. Complete the table. For the purposes of this activity, only consider information about the gigabit trunk ports. The fast Ethernet ports are access ports that have end devices connected and are not part of the inter-switch trunk-based spanning tree. All right, so therefore we only are focusing on the gigabit Ethernet ports and not the fast Ethernet ones. All right, so let's go over to our table here, and it says Packet Tracer uses a different link light on one of the connections between the switches. All right, so we need to verify it over. So let's go over to our switch 1. And let's enter the command given. In this case, it'll be, let's go to privilege exec mode by entering the enable command. And now let's show spanning tree VLAN 1. All right, so I've created a table here similar to the one given, and we need to verify it. So what status is it giving? Let's see here. So switch 1 on gigabit 0/1 interface, the status is indicating forward. So it'll be F in the forwarding state or status. Is it the root bridge? No, it's not. We can see here that the root bridge ID is this one listed, and this root bridge ID is different. So the address would be 00 for this specific switch 1. And the root bridge ID is a different one. So with that being said, let's go ahead and fill out the chart or the table here. So gigabit 0/2 is also in a forwarding state. Is it the root bridge? Again, is no on both. However, we can see that the root bridge here, based on switch 1 interfaces, is out of gigabit 0/2. That means that it'll be going out of this interface here, pointing towards switch 2. So we'll confirm that later on. Now that we verify switch 1, let's go over to switch 2 and enter the same command. Let's go ahead and escalate to privilege exec mode, and now let's input the show VLAN spanning tree. Oh, I'm sorry. Show spanning tree VLAN 1 command. All right, and let me bring up my table here and fill out the spaces. So switch 2. Let's take a look here. So switch 2, is it the root bridge? Indeed it is. This is the root. The bridge is the root. It actually states here explicitly, and it's giving the address of the switch itself. So you can see it matches. Not only does it match, but it explicitly indicates, hey, this is the root bridge. All right, so now let's go ahead and fill out the table. So switch 2 interface gigabit 04/1. It is in a forwarding state, FWD, and switch gigabit 04/2. It's also in a forwarding state. So let's go ahead and fill that out. And is this the root bridge? Indeed it is. Yes. All right. So moving along, now let's go ahead and verify it in switch 3. Same thing. Let's go ahead and escalate to a user privilege exec mode, and let's enter the show spanning tree VLAN 1 command. And again, this one does not show the message indicating it's the root. It's just listing the address of the root bridge, and it's giving this itself the address listed, bridge ID listed here. And the states, again, it's one is blocking and the other one is forward, so forwarding state. So let's go ahead and fill those charts. So switch 3 gigabit 04/1 interface. It is in a forwarding state. Is it the root bridge? We've confirmed it is not, so it's a no. And gigabit 04/2, it's in a blocking state. And again, is it the root bridge? No, it's not. All right, so that's confirmed. Let's move along and see some of the lab questions. So let's take a look here. What do you think this link light means? All right, so we see an orange light. That light means that the port is in a blocking state to prevent a logical loop. Let's see, what path will frames take from PC1 to PC2. So from PC1 to PC2, the path will be essentially PC1 sends the packet over to switch 1, and then switch 1 sends it over to switch 2, and then from switch 2 it'll go over to PC2. Yes. Why do the frames not travel to switch 3? Because the STP has logically disabled the path between S3 and S2 to ensure there's only one active path at a time, which will be this. Why has spanning tree placed a port in blocking state? That is essentially just to prevent layer 2 loops, again, which cause broadcast storms and MAC table instability networks with redundant physical cables. All right, so let's go on to part 2, observe spanning tree convergence. So step 1, remove the connection between switch 1 and switch 2. Open the CLI window on switch 3 and issue the command show spanning tree VLAN 1. Leave the CLI window open. All right, so let's go ahead and try that now. So over to, which one is it? Switch 3. So let's go over to switch 3. And again, let's do the show spanning tree VLAN 1 command. Now select the delete tool from the menu bar and click the cable that connects switch 1 to switch 2. All right, so in this case, let's go over to our delete table. So here we are. No, cancel this. We don't want to delete this part. So let me move this CLI over and then delete. And we need to delete the link between switch 1 and switch 2. Okay. Let's see. And then observe spanning tree convergence. Nothing's changed. Nothing's changing. Is there any change happening? Okay, so I do see it's changed from forwarding to listening. Oh, okay, now I see the change is change the status to learning from listening. Okay, so I guess we just have to be a little quick here so we don't miss the changes. Okay, and there it goes. So we see that it's changed from all the status all the way to forwarding. Alright, so part 8, we've done that. Select the tool, we've completed that. So now step 2, observe the spanning tree convergence. Alright, so we've done the CLI and we saw how the switch 3, once we remove the link between switch 1 and switch 2, how this interface became in a forwarding state, and if change the port pretty much transitioned through the STP states, which went from blocking to listening to learning and finally to forwarding. So we saw how the codes change, or the statuses change again, from BLK to LIS to LRN and finally FWD. Alright, so let's see here. Part B, use the up arrow key to recall command and issue repeatedly. Okay, we've done that. So let's see, what do you see happen on the statuses on gigabit 04/2 port during this process? I've explained that. It went through the 4 stages of the STP states, which is blocking, listening, learning, and lastly is forwarding. Alright, so now part C, the last part here, shows verify connectivity by pinging from PC1 to PC2. Your ping should be successful. Alright, so let's go ahead and confirm that. PC1 and PC2. So again, the IP is 192.168.1.101, and indeed it is successful. Alright, and the last question, are any ports showing an orange link light that indicates that the port is in spanning tree state other than forwarding? Why or why not? I don't see anything orange. I see everything's green. In this case, the answer is no. All lights are now green since the link between switch 1 and switch 2 was removed. The physical loop no longer exists. STP sees there is only one path left, which is here from switch 1 over to switch 3. So it moves all remaining ports to a forwarding state. Alright, so thanks everyone again for joining me today on another Cisco Packet Tracer Lab. Please like and subscribe for future videos. I appreciate that. And again, I like to reiterate that it is very important to practice on these labs in the quest or journey to achieving the CCNA certification. So thanks everyone. Hope everyone has a great day. Until the next video.